All right, welcome to the Explainer. Every single time you browse the web or stream a movie or buy something online, there's this secret conversation happening in the background. It's all run by a super strict set of rules. Today, we're going to decode that secret language. We're talking about network protocols. I mean, it really feels like magic, right? It's just instant. But behind the scenes, your computer is having this incredibly fast back and forth chat with another computer, maybe on the other side of the planet. And it's all this complex dance run by a very specific set of rules just to make sure your request lands in the right place and you get the right stuff back. And honestly, thinking of it like a postal service is a pretty spot-on analogy. When you mail a package, you've got rules, right? You need the right address, the right postage. Well, on the web, network protocols are basically those exact same kinds of universal instructions. They are the shared language that makes sure your digital package is addressed correctly, sent out, and gets where it's going without a hitch. Okay, so let's actually follow that package on its journey. It all starts with your browser writing a message to a server. And the specific language it uses for that request? That's the Hypertext Transfer Protocol, or as we all know it, HTTP. HTTP is, for all intents and purposes, the language of the web. Whenever your browser wants to load up a page, it fires off an HTTP request to the server. It's basically just saying, hey, can you please send me all the files for this website? It's the absolute foundation that lets us do everything from clicking links to jumping from one page to the next. Now, inside that HTTP language, there are these specific commands, which we call verbs. They tell the server exactly what you want to do. The most common one you'll see is a GET request. That's just you asking to get a web page. But say you're filling out a contact form or uploading a picture, you're probably using a POST request to create something new on the server. PUT is for updating something that's already there. And delete, yeah, I think you can guess what that one does. All right, so your HTTP message is all written up. Now you've got to pick a delivery service to actually send it. And on the internet, you've got two main choices. And they have very different ways of doing things. We're talking about TCP and UDP. And this is where things get really interesting, because it's all about a fundamental trade-off. Think of TCP as your super reliable certified mail. It sets up a connection, it double-checks that every single piece of data gets there, and it makes sure everything is put back together in the right order. It's rock solid. But all that checking, it slows things down. Then you've got UDP. That's more like sending a postcard. You just fire it off and, hope it gets there. It's way, way faster because there's none of that error checking. And this really shows you why sometimes you'd absolutely choose speed over perfect reliability. Just think about a live video stream or when you're playing an online game. If one tiny little piece of data, like one pixel, gets lost along the way, who really cares? What's way more important is that the next bit of data shows up instantly. You'd much rather have a tiny glitch than a long, annoying buffering delay, right? That's exactly where UDP is the hero. Okay, but what if your package isn't just a game update? What if it's something sensitive, like your credit card number or a private message? You're not going to send that on a postcard, right? No way. You need a secure, tamper-proof envelope. And that is where HTTPS comes in. You see that S at the end of HTTPS? That stands for secure. And I'm telling you, it might be the most important letter on the entire web today. What it means is your whole conversation with the server is scrambled up using really strong encryption. It basically creates this private, secure tunnel, making your data completely unreadable to any hackers or anyone else trying to eavesdrop on your connection. And how does it do this? Through something called the SSL/TLS handshake. And this all happens in the blink of an eye. Think of it like a secret handshake. First, the server shows its ID, a digital certificate, to prove it's legit. Once your browser says, yep, you're who you say you are, they both secretly agree on a unique encryption key just for this one session. That key becomes the secret code that scrambles everything from that point on for you and only you. Okay, so our message is written with HTTP, our package is sealed up tight with HTTPS, now what? Well, now let's talk about upgrading the whole delivery system to handle the crazy demands of the modern web. And for that, we have HTTP/2. So the first big upgrade is all about language. The old HTTP/1 used plain text. HTTP/2, though, it speaks binary. That's the native language of computers. And because of that, it's just so much more efficient for machines to understand. It means less chance of errors and a way faster conversation from the get-go. But this next part is the real game changer. It's called multiplexing. See, in the old days of HTTP/1, if one file was slow to load, it would hold up the entire line of everything else behind it. It was a huge bottleneck. With multiplexing, it's like a delivery truck can load up all the pieces of a website at once, the text, the images, everything, and send them all jumbled together over one single connection. It's just insanely efficient. And finally, number 3, it shrinks the shipping labels. Seriously, every single request you send comes with a bunch of extra info, and a lot of it is repetitive. HTTP/2 uses this really clever compression called HPAC to basically cut out all that redundant data. This saves a ton of bandwidth and makes every single request that little bit faster. So when you put it all together, what's the takeaway? It's that these protocols, they're the invisible engine that powers our entire digital world. They started out as simple text requests, and now they've evolved into this secure, incredibly efficient delivery system that's built for the kind of speed and complexity we just expect from the internet every single day. And the thing is, this evolution, it never stops. We're already seeing the next step with things like HTTP/3, which builds on all these amazing ideas. And it leaves you with a really fascinating question to chew on. As our world gets even more connected and we demand even more speed and security, what's next? What new rules are we going to invent to run our digital lives? It's definitely something to think about.